Scattered across the most distant reaches of space are objects so luminous they outshine entire galaxies of 100 billion stars. They are not stars, and they are not galaxies. They are quasars, the brightest steady beacons in all the cosmos, and they are powered by the darkest things we know. When astronomers first found them in the 1960s, quasars looked like ordinary faint blue stars, but their light made no sense. They named them quasi-stellar radio sources, soon shortened to quasars, and the puzzle of what they truly were would take years to crack. The first clue was their light, stretched dramatically toward the red end of the spectrum. That redshift meant one staggering thing. Quasars were not nearby stars at all. They were billions of light years away, among the most distant objects ever seen, and unimaginably bright to be visible at all. To shine across billions of light years and still appear as bright as they do, quasars must pour out staggering amounts of energy. A single quasar can outshine its entire host galaxy, blazing with the light of 1 trillion suns from a region smaller than our solar system. What could produce so much light from so small a space? The answer is the most extreme object in physics. At the heart of every quasar lies a supermassive black hole, millions or billions of times the mass of our sun, devouring everything that strays too close. It seems a paradox that a black hole, which traps light itself, could power the brightest objects in the universe. But the light does not come from inside. It comes from the matter falling in, heated to ferocious temperatures as it spirals toward the point of no return. The doomed matter forms a vast flattened whirlpool called an accretion disk. Friction and gravity squeeze it until the inner edge glows hotter than the surface of any star, blasting out light across every wavelength, from radio waves to violent X-rays. This is not a gentle process. The disk can span a region larger than our entire solar system, churning at a sizable fraction of the speed of light. In its heart, matter equal to many suns may be swallowed every single year. Not everything falls in. Twisting magnetic fields seize some of the matter and hurl it back out, firing 2 narrow jets from the poles at almost the speed of light. These beams can stab outward for hundreds of thousands of light years, far beyond the host galaxy itself. Where these jets slam into the thin gas between galaxies, they blaze in radio light, forming enormous glowing lobes. Some of the largest structures ever created by a single object in the universe are the twin plumes flung out by a quasar's jets. If one of those jets happens to point straight at Earth, the quasar looks even more extreme, flickering and flaring with dazzling speed. We give these aligned quasars their own name, blazars, and they are among the most violent, variable objects in the sky. Here is the strangest part. Almost all quasars are billions of light years away, which means we see them as they were billions of years ago. They are creatures of the young universe. In the cosmos around us today, the great quasars have largely fallen silent. In the early universe, galaxies were packed with gas and crashing together, feeding their central black holes a constant banquet. As that fuel ran out and the chaos settled, the quasars starved. The brightest era of the cosmos quietly came to an end. The supermassive black holes did not vanish. They simply stopped feeding. Most large galaxies, including our own Milky Way, harbor one of these sleeping giants at their center, quiet now, but capable of roaring back to life if enough matter ever falls in. The black hole at the center of the Milky Way weighs about 4 million suns, yet it is silent today. Billions of years ago, when our galaxy was young and gas-rich, it too may have blazed as a quasar, a beacon visible across the universe. Because they are so bright and so distant, quasars are precious tools. Their light has traveled across most of the history of the universe to reach us, passing through everything in between, and carrying the story of that long journey written into it. As a quasar's light passes through unseen clouds of gas scattered across billions of light years, those clouds leave their fingerprints on the beam. By reading them, astronomers map the hidden matter between the galaxies, using quasars as backlights for the dark cosmic web. Sometimes a galaxy sits directly between us and a distant quasar. Its gravity bends the quasar's light around it, and a single quasar can appear as two, four, or even a ring of images, a striking proof that gravity warps the very path of light. The farthest quasars we have found shine from a time when the universe was less than 1 billion years old. Their light set out before the Earth, the Sun, or even most of the stars around us existed, making them among the oldest things human eyes have ever glimpsed. These early quasars pose a deep puzzle. To shine so brightly so soon, their black holes had to grow to billions of times the mass of the Sun astonishingly fast. How they reached such size in so little cosmic time is a question astronomers are still racing to answer. A quasar does not just sit quietly at the center of its galaxy. Its blazing radiation and powerful jets blast gas outward, heating it and driving it away. In doing so, a quasar can choke off the birth of new stars, shaping the fate of the entire galaxy around it. Astonishingly, the mass of a galaxy's central black hole is closely tied to the galaxy itself, as though the two grew up together, regulating one another across billions of years. The monster in the middle and the galaxy around it are bound in a strange, lifelong partnership. When two galaxies collide, gas is flung toward their centers, and dormant black holes can suddenly wake. Astronomers catch galaxies in mid-merger blazing with reignited quasar light, a glimpse of how the universe lit its brightest fires in the first place. A quasar does not shine in visible light alone. It pours out radio waves, infrared, ultraviolet, X-rays, and gamma rays all at once. To truly see one, astronomers must combine every kind of telescope, building a picture of an object that screams across the entire spectrum. Quasars are not steady. Their brightness can change in days or even hours, and that rapid flickering reveals just how compact the engine is, no larger than our solar system, despite outshining a galaxy of hundreds of billions of stars. By timing how the light flickers and echoes through the surrounding gas, astronomers can actually weigh the hidden black hole at a quasar's heart. From billions of light years away, we measure the mass of an object we can never directly see. For decades, the black hole stayed purely theoretical, inferred but never seen. Then telescopes across the whole Earth joined together and captured the silhouette of one, a dark circle ringed by glowing gas, confirming the engines behind quasars are exactly what we believed. Quasars rewrote our picture of the cosmos. They proved that supermassive black holes are real and common, that galaxies and their black holes evolve together, and that the early universe was a far wilder, brighter place than the calm sky we see tonight. In a strange way, the most destructive objects in the universe helped create the order we see. By regulating star birth and stirring the gas of young galaxies, quasars left their mark on the structure of everything, including the quiet galaxy we call home. So when you look at a quasar, you are seeing the brilliant youth of the universe, light from black holes that blazed before the Earth was born. They are the lighthouses of the cosmic dawn, still shining across the dark to tell us how it all began.